Okay, so this is problem number 15. Here we go. This is problem number 15. And the question that was asked was just if I could walk you through and give you an idea of how to approach one of these problems, and I would love to. So let me kind of take you through my thought process. Whenever I start a problem, the very first thing I do is define my variables. Step one always comes down to define your variables. Figure out what it is you are searching for, what it is you're trying to answer. Usually you can cheat and jump to the last sentence of the problem and find it, but sometimes you can't. You have to search. But so you can see how many compact fluorescent light bulbs. Okay, so right here we're going to say how many compact fluorescent light bulbs, and then also how many feet of insulation should you purchase. So I might do x equals number of bulbs, and y is the number of feet of insulation. And the reason I find it to be extremely important to identify your variables, to define your variables, is now I know every single equation I write, it better somehow correlate x and y. It better correlate the number of light bulbs I'm purchasing and the number of feet of insulation that I'm purchasing. And that also helps me read the problem now and kind of break it down break the information down. So now let's go through the problem. You're thinking of making your mansion more energy efficient by replacing some of the light bulbs with compact fluorescents and insulating part of your exterior walls. Each compact fluorescent costs $4. Okay, so this is talking about my variables. So I am now going to come up with my constraint equations, or the things that are limiting me. So the first thing I have here is I have a cost. And I know my light bulbs are $4. So for each light bulb I buy, it's going to cost me $4. So if I buy 10 of them, it would cost me 40. If I buy 20 of them, it would cost me 80. Done. Okay. Um, Now I also have another equation that's going to pop up right here. It cost $4 and saves me an average of $2 per year. So savings $2 per light bulb. Okay. Now, and each square foot of wall insulation, up there it is, costs $1. So plus 1y. So I don't need to write the 1. There's my cost. And saves, oh, here's our savings, an average of 20 cents. So you can see our savings maybe we'll do here is we'll do our savings in red. So you can see here's a savings of $2, savings of 20 cents. Okay. Yeah, 20 cents. Okay, so plus 0.02y. There we go. So now I'm saving 20 cents per square foot of insulation. My mansion has 250 light fittings. So therefore, just how many, I have a limit here. I'm saying, all right, if I have 250 light fittings, then I know X has to be less than or equal to 250. I can't buy more light bulbs than I could put into the sockets. And then I also know there are 3,000 square feet of uninsulated wall. So therefore, my insulation has to be less than or equal to 3,000. Okay, so I hope this is kind of getting you the idea of how I attack one of these problems. And so this would be, again, just more limits, things that are limiting me. Okay, let's keep reading. To impress your friends, you would like to spend as much as possible, which is completely backwards from us normal folk, but whatever the case. So our goal is to maximize this right here. So therefore, we're going to call this our cost, and our goal is to maximize that. Weird, but okay. Um, and we also want to save no more than 800 feet. $800 per year. So in our savings, we want to save no more than 800. So therefore, these two things need to add up to be, I'm just going to sneak in here. These things need to be less than or equal to 800. Sorry about that. Had to sneak that in there. Okay. Um, okay, and then that's it. So now all these equations are statements. You know what? Let me pause the video and make that a little cleaner. It's going to bother me. There we go, much better. Okay, so now I hope that helped you with the setup. I hope that helped you with the thought process. So for me, step one, figure out what your variables are. Figure out what the things you're trying to solve for are. Step two, go through and find your big ideas that come from the word problem that relate those variables. And then step three, now we're ready to start solving. And now this problem just becomes like the other problems that you've already done. So I'm guessing usually where students have a hard time is the setup, because you're on problem 11. So therefore you've already figured out 1 through 10. So you've got the algorithmic portion down. So now it's the word problem setup type stuff. So this thing here, since this is the cost is what we're trying to max, this would be our objective equation, and the other two would be our constraints, the things that are limiting us. So we're going to just take our constraint concept and we'll slide that over here and say, look, these things over here are our constraints. There's our objective. Okay. All right. So now for our solving, we are going to graph our constraints, find the shaded region. So we're going to graph and shade, and then we're going to test the corner points. That did not come out. Let's try that again. Test the corner points in the objective equation. Okay. I hope that helps. Let me know if you have any questions or if you need to see it actually solved out. But my guess is that at this point you're probably doing just fine. Okie dokie.